Solutions for Quiz 6, Math 243. Two problems here. First one, talking about proportions. It says that 40% of the time I spend, 40% of the time I spend too long thinking of stupid examples for quizzes. Doesn't matter what it is, all that's important is that 40% is giving me my population proportion. In other words, P is equal to 0.40. So determine / justify the shape, center, and spread. Hopefully you knew this was coming. Of this sampling distribution of the proportion. Key fact here is that my sample will have 50 quizzes. What that tells me is that n equals 50. The number of observations in my sample size is 50. So for shape, answer in this class is always going to be approximately normal, because that's the only distribution we know how to study, or we have information about. Why? The criteria when you're talking about proportions is we need n times p times 1 minus p to be greater than or equal to 10. To prove to you that this is true, n is 50, p is 0.4, and 1 minus p is 0.6. And if you multiply those all together, you get 12, I think. Yeah, I think that's right. Which is greater than or equal to 10. Cool, it's approximately normal. I can continue with the problem. Center. The symbol we use is mu sub p hat. What this is saying is that every sample proportion is different, but the overall average of all these sample proportions, it's expected to just be the population proportion, p, and that's equal to 0.40. The spread, same thing. My sample proportions, p hat, they're different. So I can talk about the standard deviation of those sample proportions. In fact, there's a formula that gives me the standard deviation of the sample proportions, and it is the square root of p times 1 minus p divided by n. So in this specific case, it's the square root of 0.4 times 0.6 divided by 50. And I'll just leave it like this. You can calculate this number if you feel like it. I'm not even going to bother. Okay, now that we have all this information, we can answer questions. The first question says, determine the probability that in more than 50% of the above sample I spent too long. Well, the way we do this is we draw a picture. Using this information up here, I draw something that's approximately normal. It's supposed to look like that. Center, 0.40. Okay, I'll put 0.40 in the middle. And then I want the probability that more than 50%. 50% somewhere out here, because it's greater than 40%. And more than means the area to the right of that spot. I need to figure out this area. If I figure out this area, I know the probability in question. Fortunately for me, my calculator has a function that figures out exactly this area. I guess I should pull up a calculator. You use the normal CDF function in your calculator. When you're using normal CDF, you always have to tell it the lower bound, the upper bound, the center, and the spread. Fortunately, we have all of that listed up above. So I'll type all these numbers into my calculator. I'll get some area, some probability. Expect that to be less than half, right? Because this is over to the side here. Let's see what happens. So normal CDF is under distributions. There it is, the second one there. My lower bound is 0.5. My upper bound, I don't have one, so I'll just put in the largest number my calculator understands, which is this E99 thing. It's a 1 with 99 zeros after it. And then the center was 0.4. And the spread was the square root of 0.4 times 1 minus 0.4, which is 0.6, divided by 50. Square root of that entire mess. Hit enter, and I get this number, 0.07 something. Let's do, I guess, 4 decimal places is what your homework's been doing, so I'll do 4 decimal places. 0.0745 if you round it off. Or 7.45% if you're a percentage type. Determine the probability that more than 50% of the above sample I spent too long. It looks like 7.45% is that probability. All right, moving on, part C. You might have guessed that there would be a question where you use normal CDF and a question where you use inverse norm. In fact, that's exactly what's going on. What proportion of my sample is so small, so I'm talking about some number over here, really, really small, that the probability that the above sample's proportion is less than this amount is only 5%. Note, it's giving me the probability. It's telling me that this area right here is only 5%. I know the center's 0.40. What I don't know is this point right here. Maybe I'll use P naught to represent it. You don't have to use this symbol. Fine. And I know that the probability that my sample proportion is less than this value P naught is only 5%. And so what I got to do is find P naught. I got to find this value right here. It's going to be some number less than 40% because the probability that I'm left of it is only 5%. So I got to figure it out. Fortunately, my calculator has a function built for exactly this purpose. It's the inverse norm function. When you're talking about inverse norm, you have to tell your calculator the area below the point in question. In this case, 0.05 is the area below P naught. And then the center and the spread. Those are the same as above. Oops, 0.4 times 0.6 over 50. Type all this into your calculator, you get your answer, you're done with this problem. So inverse norm, that's also under the distribution menu. It's the third one on this list. Inverse norm, 0.05 is the area below, 0.4 is the center, and the spread is the square root of 0.4 times 0.6 divided by 50. And if I entered all of that right, looks pretty good. I'm going to hit enter and I get a value. I'm expecting this value to be some number less than 0.40. So I don't know, maybe 0.3 or so. There you go, 0.286. So what this is saying is that 28.6% is such a small probability that if I went out and got a whole bunch of samples, or if I went out and got one sample of 50 of these quizzes, I'd expect the proportion of those quizzes that took me too long to be less than 28.6%. I'd expect that to only happen 5% of the time. This right here is your answer. That's the end of this question. There's another question. Fortunately, this one's a little bit easier. Well, I don't know. I guess easy is subjective. We're creating confidence intervals here. Now suppose that in a random sample of 50 quizzes, all right, n is still equal to 50, the amount of time that I spent thinking up a stupid example is right skewed with a sample mean, x bar is equal to 10, and a sample standard deviation, s, which is equal to 5. And my confidence level is given to me to be 95%. So what it wants me to do is create a 95% confidence interval for the average amount of time that I spend thinking up stupid examples on all these quizzes. Make sure to include shape, center, spread, and a labeled sketch of the distribution. All right, so let's do it. Shape. Shape's kind of a trick question, I guess. I don't know if maybe that's saying it a little bit. Maybe it's not really a trick question, but it does say up here that the amount of time that I spend is right skewed. So you're like, ah, shape's right skewed. No, it's not. It's approximately normal. It's always going to be approximately normal. Our calculator can't do anything, at least not that we know, with right skewed distributions. It has to be approximately normal. Wait, why did it say right skewed? The parent distribution is right skewed, but what I'm talking about is the sampling distribution. And the sampling distribution is approximately normal because n is greater than or equal to 30. It takes distributions that are right skewed and makes them approximately normal. This is a central limit theorem going on here. Center, mu sub x bar. X bar is my sample average. It will always be different, but the overall average of these averages, actually I don't want to use this notation, sorry. My center, I'd like to use mu. I'd like to use the population average, but I don't know the population average. That's what I'm creating a confidence interval for. Next best thing is my sample average. My best guess, my point estimate, is my sample average, which is 10. Spread, I'd like to use sigma over root n. Unfortunately, I don't know sigma. I don't know things about the population. So next best thing is to use the sample. Sample standard deviation divided by the square root of n. So 5 over root 50. And with all this information, once you have shape, center, spread, you can draw your picture, answer the question, and be done with the quiz. So I'm trying to create a 95% confidence interval. So I have this spot in here, the center, that's 10, and I want to pick some value way out here and some other value out here so that the area in between those 2 points is 95%. This area, this shaded region, 95%. I got to find these two values. You could figure out those two values using inverse norm. Well, not really. You'd have to use inverse t, because this is actually a t distribution and not a z distribution. The reason it's a t distribution is because not only are we estimating mu, we're also estimating the standard deviation. If you know sigma, the population standard deviation, it's a z distribution. But you don't. You have to estimate sigma using s. When you estimate a second parameter, what that does is it changes your distribution from a z distribution to a t distribution. So you could answer this question using the analog of inverse norm, the thing we used above. It's actually called inverse t if your calculator has it. But there's a much easier way. Built into your calculator is a confidence interval. So if you hit the stat button here and then go over to tests, if you scroll down a little bit, you'll see all these things that end in interval. The one we want is t interval because, again, this is a t distribution because we don't know sigma. So I'll hit enter on t distribution. And then what it says is, all right, do you have the raw data itself? Do you have the amount of time that each of these 50 quizzes took? Or do you have statistics about the data? And in this case, I don't have the data. I don't say the first time it took 11 minutes, the second time it took 8 minutes, the third time it took 12 minutes. I don't have that. All I know is that in total there were 50 and the average was 10. I only have statistics about the data. X bar was 10. S, the sample standard deviation, was 5. And N was 50. Confidence level, 95%, which is exactly what it asked for. I hit calculate, and what it will do is give me these two values right here. Thinking for a minute. Thinking for another minute. There we go. So what it says is that if you want to make a 95% confidence interval of a t distribution, if your center is 10 and the standard deviation for a single observation is 5, and n is 50, the points that you have to pick are 8.579 and 11.421. What you don't need to write is, so I'm 95% confident that the unknown value of mu, the population average, is between those two values, 8.579 and 11.421. You don't have to write this, that's why I put it in parentheses, but that's kind of the conclusion. That's what we're doing here. The population average, I don't know. I'll never know, but I can estimate it just based on my sample. And just based on these 50 quizzes that I looked at, I'm 95% sure that the average for all quizzes would be somewhere between these two values. That's a confidence interval, and that's the end of this quiz.